go to Create, and once again it's a geometry displacement. However, we'll add a second loop now. We'll make this into loop 2, and we'll give it the same name as we did before, call it gap, and the same number of steps as we had before. Now we have to select what geometry applies to this gap parameter, and once again it'll be the core region, and we'll have the same displacement. Initially we'll be at a height of 15 millimeters above the stop, and the final position will be 5. Now when I click on Apply Create, you'll notice that in the Parametric Setup dialog box, now we have a nested loop structure. So we have the outer parameter that's creating the size, and the inner parameter that varies the gap. So now we'll have, instead of 11 different models, we'll have 55 models created. So we'll have 5 different sizes of solenoid, and for each of those 5 sizes we'll run it through the full performance range over a series of 11 steps, and we'll calculate the force on the region for each case. Now, once again, we've already done this, so I'll just open up the results file. And now, if we look at the parametric results, and we'll play the animation for this one. So you can see here's the first initial size of solenoid going through all the range of motion. Then the diameter of the core is increased, and once again you go through the same range of motion, and it continues on this way. I'll just speed this up. So here we've combined the two ideas. We have an outer parametric loop that creates prototypes of different sizes, and an inner loop that runs each prototype through its range of motion as a performance test. Now, in this situation, if we were to graph the results, we now have the option of having either the gap parameter or the size parameter as the independent variable, the x-axis variable. We'll choose once again the gap, and we have the option of adding a second independent variable. Like if we were to plot it now, it would plot just the results from the first size. That would be identical to what we obtained earlier. Oh, pardon me, instead of the it's a negative force, I'll plot the magnitude of the force. Okay, so this is identical to what we had before, basically. But we can also, at the same time, specify a second independent variable, and this will produce a family of curves. So we'll graph those results, and now we have a curve, a performance curve for each size variation. So the bottom plot corresponds to the initial size, and then as the size of the solenoid increases, we then get a larger force for each position of the solenoid.